Everyone, so today we are going to be talking about standard deviation. So standard deviation itself is a measure of how spread out the numbers are from the center of the data, which is also the mean. Okay, so a low standard deviation means that most of the numbers are close to the mean. Okay, and a high standard deviation means that the numbers are spread out or far from the mean. Okay, and so this is the Greek letter sigma, and that's what we use for standard deviation. Okay, so if we see the lowercase sigma with an x, that is the standard deviation of the whole population. Whereas if we see an S with an X, that they're asking us for the standard deviation of just a sample, which is smaller. Okay, so this right here is called the standard deviation bell curve. Okay, and so you can see we have it broken up here. Okay, and so the mean is always going to be at the center. Okay, and then here we have each of these steps represents one more standard deviation away from the mean. Okay, so from here to here, that's one standard deviation, and then this is one standard deviation in the other direction. Okay, and so this central section here is where the bulk of our data is going to be. Okay, and that is going to be 68.2% of the data. Okay, so the standard deviation bell curve, how it works is we format it so that 68.2% of the data is within one standard deviation away from the mean. Okay, then our next section is going to be 2 standard deviations away, right? So that's going to be this part here and this part here, right? Okay. And so the blue part here in combination with the purple part encompasses 95.4% of the data, okay? Okay, and then we also have this section here, right? This is within 3 standard deviations from the mean. Okay, and so this one is essentially 99.6% of the data is within 3 standard deviations of the mean. Okay. Alright, so let's go ahead and take a look at this example problem here. So 95% of students are between 1.1 and 1.7 meters tall. The standard deviation of the data is 0.15 meters. Create a bell curve for this data. Okay, so first what I need to do is I need to calculate the mean. Okay, and so what I'm going to do to calculate the mean is I'm going to average these two numbers. Okay, so my mean is going to be 1.1 plus 1.7 divided by 2, and that equals 1.4 meters. Okay, so now I can draw my baseline here, and I know that 1.4 is going to be at the center, right? Because we always put the mean at the center of our bell curve, okay? So now I'm gonna kind of draw my bell curve here. They're always going to be roughly the same shape, right? And then I need to divide it into the divisions that I had before, right? So on either side, and actually I'm gonna straighten out this line a little bit because it didn't get fully on center of my bell curve. Okay, so I'm gonna break it up so that it looks just like my other picture did, right? So this is 1 standard deviation, this is 2 standard deviations, then we also need 3 standard deviations in either direction, right? And so if we look at our picture from the other page, we know that this has to be 34.1%, right? And then this has to be 13.6%. This has to be 2.1%. And this has to be 0.1%, right? Okay, and then same thing with the other side. Okay, and so I also know, right, that each of these is 1 standard deviation more, right? And they tell us that my standard deviation is 0.15 meters. So I know this is 1.4, so to get this one, I'm going to do 1.4, and I'm going to add 0.15 to it. Okay, that's going to give me 1.55. Okay, I'm going to do that again and add another 0.15, and I get 1.7. And then I'm going to do that one more time, and I get 1.85. Okay, now we're going to do the same thing the other direction. Instead of adding 0.15, I'm going to subtract 0.15. So I'm going to start out with 1.4, subtract 0.15. That's going to give me 1.25. Okay, I'm going to do that again. Subtract 0.15, and that gives me 1.1. And then I'm going to do it one more time, and it gives me 0.95. Okay, so that would be how you make a bell curve given a set of data. All right, so now let's look at this next problem here. It says you are comparing the different heights of these dog breeds. The heights at the shoulders are, and then they give a bunch of heights, and then they want us to calculate the standard deviation. So we can actually do this using a calculator. So our first step is we need to enter the data into our calculator, okay? And so we're going to do that by entering it into a list. If you have a TI-84, or it's called a spreadsheet. If you have a TI Inspire calculator, okay? So like here I have a TI-84, okay, so that's what I'm going to be using, okay? And then our second step after we enter the data is going to be to do one variable statistics. Okay, so if this is my graphing calculator, okay, what I'm going to do is I'm going to find the button that says stat. So mine says stat right here. So I'm going to hit stat, and then right here it says edit. So I'm going to go there and hit enter, okay? And now what I want to do is each of these are different lists. We just need one, okay? And so I'm going to type all of these values in to my graphing calculator. So I'm going to do 600, and then you hit enter and it'll show up there, okay? I'm going to do 470, 170, 430, and 300, okay? So now all of those are in my list, okay? So now I'm going to click stat again, and then instead of clicking anything here, I'm going to hit the arrow so that I'm at calc, and then once you're at calc, see how it says one var statistics? That's what we want, so I'm going to hit enter, okay? And then the list, here it says L1. If you used, L2, L3, something like that, you'll need to make sure that it is whatever list you entered. And then after that, I'm just going to go here and hit calculate. Okay, so now this is why it's important to know what all of our symbols mean, right? So if you remember, this, the x bar, that's going to be our mean. Okay, so our mean is going to be 394, right? And then we want the SX, right? That's the sample mean. And so we are going to look at this one here, and it's 164.7. Okay, and you'll want to go out 2 decimal places for that, so it'll be 164.71. Okay. All right, so now we are going to look at these 2 data sets here. We'll see if I can get it to focus here. There we go. Okay, so we are going to compare and contrast these. Okay, so you can see here that they have the same mean, right? But they have a very different standard deviation. Okay, so both sets have the same center of 61.44, right? That's our first thing. Okay, and then we can also see that set A is going to be less clustered around the mean and more spread out because it has a larger standard deviation. Okay. Okay, and so to cite that, we can say that 38.24 is greater than 19.4. Okay. All right, let's go ahead and look at another example here. Okay, so they give us 2 different data sets and they want us to find the standard deviation and the mean for both of those. Okay, so I'm going to use my graphing calculator for each of these. Okay, so what I'm going to do is I'm going to hit stat, I'm going to hit edit. Now I'm going to show you how you can use multiple lists since we have 2 of these. So my first one, I'm going to enter this data set, right? So I'm going to do 42, I'm going to hit enter, I'm going to hit 18, hit enter, 75, enter, 31, hit enter, 105, 48, 57, 93. Okay, there's my first data set. Now I'm going to go, I just hit the over arrow to get to list 2. I'm going to go 51, 48, 67, 75, 55, 42, 73, 61. Okay, and make sure you hit enter on that last one, otherwise it won't be included. So now I'm going to go to stat, going to go to calc, going to go to one variable statistics. So right now it's listed as L1, so that means that it's going to do this one first because this one was my L1 and this was L2. Okay, so if I go ahead and do that, okay, I find out that my standard deviation is going to be 30.25 and my mean is going to be 58.63. Okay, now I'm going to hit so if you hit second and then you can hit mode right here because where it says quit right above it. Okay, so now what I'm going to do is I'm going to go to stat, I'm going to go to calc again, but instead of list 1 I want list 2. So I'm going to look here and I see L2 is written right there in blue, right? So I'm going to hit second and then I'm going to hit 2, and if you see now it says L2. Okay, so that's going to do my second one. Then I'm going to hit calculate. Okay, so I can see my standard deviation is 12.01 and my mean is 59. Okay, so now they ask us to compare and contrast the values, right? So we can see that they have almost the same center, right? 58.6 is pretty close to 59, so these sets have almost the same center. Okay, and then we can see here that set A is going to be more spread out, right, because it has a bigger standard deviation. Okay, so we're going to say that set B is more tightly clustered. From the mean, or around the mean. Okay, and that's, again, that's because of its lower standard deviation, right? And again, here we can say 12.01 is less than 30.25. Okay. Awesome. So that is standard deviation.